Welcome back to another geometry lesson. Today we're going to look at parallel lines, but more specifically, when parallel lines are intersected by a line, the angles that are formed and the relationships that are created. So with that, let's hop right into it. Just to remind you, parallel lines are two lines that go on continuously, but they never intersect. I'm sure you probably already know that. Now, the reason that they never intersect is because they have the same slope. Now, often if they don't tell you that they're parallel, you'll be able to tell because they'll use this notation. They'll use what look like sort of arrowheads on the line. So that would mean that those two lines there are parallel to one another. But really our focus today is going to be on what happens when we intersect those parallel lines. So let's go right into that. Okay, what I mean by that is we're going to take a parallel line, we're going to cut it by something called a transversal line. Okay, so imagine that I have two parallel lines and I intersect them both with the same line. That line you see there in red is called the transversal line. Well, when we do that, you should notice that I've created 1, 2, 3, 4, 5, 6, 7, 8 different angles. Okay. Now, there are special relationships between those angles, and that's what we want to explore today. Some of those angle relationships are some of the ones that we've discussed in previous lessons. Okay, when you look at that diagram there, you should recognize some angles that look like they're supplementary, or you can say that are linear pairs. For instance, take a look at angles 1 and 2. They're supplementary. Or take a look at angles 4 and 2. They're supplementary. They form this straight line. 5 and 7. I mean, there's numerous examples of supplementary angles in here. On top of that, there are even some ones that are kind of hidden. If you look at angles 4 and 6, you're going to find out later on that those are supplementary as well. Okay, some other angles that we've discussed already that you should recognize and identify in this picture here is some vertical angles. Okay, if you look at angles 1 and 4, those would be considered vertical angles. Remember, they're back to back with one another when lines intersect. 3 and 2 are vertical angles. They are congruent to one another. 5 and 8 and 6 and 7. So those are all examples of some vertical angles. Now, just as a little hint, in this picture, if you choose any two angles, those angles are either congruent to each other or they will be supplementary to each other. Now, why they are congruent, we'll discuss on further slides. But just know that when you look at this picture, any two angles you choose from here will either be congruent to one another or supplementary to one another. Okay, now let's start to explore some more specific type of angles in this picture. So if you need to, redraw the picture so that you can take some more detailed notes. Okay, the first angles that we're going to look at are what we call interior angles. Okay, interior angles, as the name implies, are the angles that are inside of this diagram, the ones that are between the parallel lines. So I've highlighted those in red. Those are angles 3, 4, 5, and 6. Those are known as interior angles. Now, some of those interior angles are congruent to one another. If you look at angle 3 and you look at angle 6, we would say that those angles are congruent to each other. Now, the reason is we consider those angles to be what we call alternate interior angles. Okay, angles that are interior, but on opposite sides of that transversal line. So 5 and 4 would also be alternate interior, and they would be congruent to each other. So if angle 4, let's say, was 120 degrees, angle 5 would be 120 degrees. And our reason would be, is we'd say, because they are alternate interior angles. So again, if you're looking for a definition of what that means, they're just interior angles that are on the opposite sides of the transversal line, and they're congruent. Okay, let's explore some more angles. Let's look at the ones that are on the outside. We call those the exterior angles. So that, in this case, would be angles 1, 2, 7, and 8. They're on the outside of the parallel line. So think of it that way. Just like the interior angles, there are what we call alternate exterior angles as well. Those would be angles that are on opposite sides of the transversal line, but are congruent. So angles 1 and angle 8 would be considered alternate exterior angles. So would 2 and 7. And again, what's really important out of all this is that they are congruent to each other for that reason. So if angle 1 was, again, let's go with any angle, 130, angle 8 would be 130. Okay, I'll give you a moment to get down that definition before we look at another set of angle relationships. Okay, another set of angle relationships that we're going to look at is what we call corresponding angles. Okay, corresponding angles are angles that are in the same position, both in the top set of angles and the bottom set of angles. Now, let me describe it a little bit better. Imagine that I drew a line here that cut this diagram in half, and we had angles 1, 2, 3, and 4 on top, and 5, 6, 7, and 8 on the bottom. If someone was to ask me to describe where do I see angle 1, I would tell them angle 1 is in the top left corner of these angles. Well, if I was to look at the bottom, angle 5 is also in the top left of those bottom set of angles. So we say that angle 1 and angle 5 are corresponding because they're in the exact same position. Even better, if you can think of it this way, imagine that I could pick up all of these angles here and drop them right on top of these angles right here. Which ones would line up right on top of each other? So if you're saying angle 1 and angle 5 would, and angle 2 and angle 6, and angle 3 and angle 7, and angle 4 and angle 8 would, you'd be correct. Okay, that's what makes them corresponding. They're in the exact same location. So for that reason, if I was to give you angle 1, you should be able to figure out angle 5. Your reason would be because they are corresponding. Okay. All right, now that we know our angle relationships, let's look at a few examples where someone might ask us to find some of the missing angles based on our relationships. Okay, take a look at this next problem here. It says in the diagram below, NP and ST are parallel, and MQ intersects them. So MQ would be considered the transversal line. Really important that somebody tells us that those are parallel. That way we now know that the relationships we discussed before do exist. Now, when I look, it says, what is the measure of angle X? When I look at that right now, I don't know any direct relationship between 40 degrees and angle X. But if I work my way around this diagram, I should be able to figure out what angle X is. So there's a lot of different ways you can do it. The way that I'm going to look at it here is just my perspective. Again, you could do this many other ways. One thing I see is that if this is 40 degrees, this must be 40 degrees right here due to the fact that, and let me just erase that a little bit, due to the fact that these are what we call vertical angles. So if that's 40, this one's got to be 40 as well. All right. And this has got to be 40 due to alternate interior angles. Now, you might be thinking, well, couldn't I have said that was 40 right at the beginning because it was corresponding to the given one? Yeah, you absolutely could. And then now that I have that angle that's right next to X, I should be able to recognize, based on my previous work with angle relationships, that X and 40 are supplementary. So that's going to make X 140 degrees. Now, that took a little work for me to get there. Took a little bit of thinking, but using my relationships that I learned today and some relationships that I already knew from the past, I'm able to figure out that X is equal to 140 degrees. Okay, let's take a look at one that involves a little bit of algebra, and then we'll let you get started on your classwork. Okay, last one. Take a look at this picture. Again, we see a picture that looks pretty similar to ones we've seen before already. There's some parallel lines. There's a transversal line that intersects them. And I'm given information about, looks like angle ABC, which is 4x plus 40, and that angle on the bottom, which is W plus 115. All right, what I would need to recognize is what is the relationship between them? And hopefully you can see that those two angles are congruent because they are corresponding. Now, didn't ask for you to say what the reason was, but it's really important that you do know what some of those reasons are. So knowing that those are corresponding then allows you to know that they must be congruent. So I just set up my equation, and now I go ahead and solve. Okay, you can pause the video if you want and solve. I'm going to pause the video, do all my work, and I'll come back with the answer in just a moment. Okay, when I did my algebra, I ended up with x is equal to 25. But as I've talked to you guys about multiple times, let's make sure that we're answering the question that's being asked. Did the question ask us what, I put x, it should be w, excuse me. Did the question ask what w is, or did the question ask for the angle? So we go back, it says, what is the measure of angle ABC? All right, so they want the measure of the angle. So 25 is not the answer that they're actually looking for. So we're going to take 25, we're going to substitute it right back in up here. So I'll do this one off to the side, 4 times 25 plus 40. 4 times 25 is 100. 100 plus 40 says 140 degrees. Okay, so I've now just found out that the measure of this angle is 140 degrees. Just a coincidence that it was the same answer as the one on the last one. So there you have it. Another example of us being able to use our relationships of angles that are formed when parallel lines are cut by a transversal. Good luck, and we'll see you back here next time.